Okay, in this video I'm going to show you how I estimated the relationship between the growth rate of productivity and the initial level of productivity that's discussed in the article. Strictly speaking, you don't need to know this. This is not necessary for an understanding of the material in the article, but if you are interested, this will show you exactly how I went about estimating this relationship. Basically, we start off with the following scatter. On the horizontal axis we've got the initial level of productivity, and on the vertical axis we've got the growth rate of productivity between 1995 and 2015. And if we look at this relationship, we can see that there is a clear downward relationship between these two variables, but what complicates things is it's a non-linear relationship. So we need to think about what sort of curve to fit to this data to capture this relationship. Now, on the next slide, we can show here the sort of relationship I want to fit. It's a curved relationship where the lower the initial level of productivity, the closer to zero we are on the horizontal axis, the steeper the curve becomes. And then as x increases, so we move along the horizontal axis, the curve tends to flatten out. So it's a downward sloping relationship which becomes steep for values of x close to 0, but becomes flat for large values of x. So the question is, what sort of function do we want to fit to capture this relationship? So if we think of this curve as being a curve of the form g of x, where g is the growth rate and x is the initial level of productivity, it needs to have the following properties. First of all, its first derivative should be negative, so it should be downward sloping. But its second derivative should be positive. It should flatten out as the level of x increases. And then finally, we want it to approach the vertical axis as x becomes very small. In other words, as x tends to 0, the limit of the function should become infinite. It should become asymptotic to the vertical axis. So what sort of function would satisfy these properties? Well, there are potentially quite a lot of functions that might satisfy these properties, but the one that I'm going to try and fit to the data takes the following form. We've got g of x equals a constant a minus b multiplied by the natural logarithm of x. And I can show that this satisfies the properties that I want in the function as follows. First of all, its first derivative dg dx is minus b over x. So clearly, provided b is a positive number, x is always positive, then this is going to be a downward sloping function. It should have negative first derivative. Its second derivative, d squared g over dx squared, is b over x squared. So again, if b is a positive number, this is always going to be positive, so it satisfies this property. And then finally, it's fairly straightforward to show that as x tends to 0, g of x tends to infinity. In other words, it's asymptotic to the vertical axis. The advantage of fitting this function here, though, is although it's a non-linear function between g of and x, it is in fact a linear function between the growth rate and the natural logarithm of x. So we can use the standard least squares method to find the unknown parameters a and b. And if I apply least squares, I can estimate a and b and get the following estimates here. A hat equals 7.6532 and b hat equals 1.6980. So those are the estimates that I'm going to try out to fit to the function. So in this slide, this is the actual estimated function here shown by the solid line with these estimated parameters, and we can see that it fits the scatter reasonably well. It's got exactly the sort of shape that I wanted to capture in the function. And I've highlighted here the value for the United Kingdom here. This is the scatter point corresponding to the United Kingdom, and you can see that it's actually fairly close to my estimated relationship, which backs up the argument in the text that the growth rate of productivity for the United Kingdom is actually pretty close to what we would expect given our sample of data and given this downward sloping relationship between the growth rate of productivity and the initial level of productivity.